Brooke Canty, and today I will be talking about how much energy the sun radiates to the Earth. First, let's talk about what the sun actually is. So, the sun is just an ordinary star to the universe, but not in our solar system. It is made up of a blazing combination of gases. These gases are actually in the form of plasma. They consist of hydrogen and helium, and a very small percentage is made up of other gases and metals. When it comes to size, the sun alone contains 99.8% of the total mass in the solar system and has a diameter of roughly 1.4 million kilometers. To put this in perspective, this is almost 110 times the diameter of Earth and means that about 1 million Earths could fit inside the sun. So where is it and how far away is it from Earth? So the average distance from the sun to the Earth is about 150 million kilometers. This has an effect on the speed in which solar energy can reach the Earth. For instance, light travels at 300,000 kilometers per second, so dividing one by the other gives you 500 seconds, which converts into 8 minutes and 20 seconds. This is how long it takes for the energy to reach the Earth. The distance between the Earth and Sun also changes. This is because the Earth travels on an elliptical orbit path around the Sun. The distance between the two ranges from about 147 to 152 million kilometers. Now, where does this energy come from? Almost all of the energy available at Earth's surface comes from the Sun, but the Sun gets its energy from the process called nuclear fusion. This process occurs in the Sun's core or interior, where temperature and pressure are extremely high. In this process, 4 hydrogen nuclei are fused, forming a helium nucleus, and during the process, some of the mass is converted into energy, which is then released. This energy eventually makes its way to the outer regions of the Sun and is emitted away in the form of energy known as electromagnetic radiation. A particle of this radiation is known as a photon, and the radiation is spread in the form of electromagnetic waves. Electromagnetic waves are waves that can cause charged particles, such as electrons, to move up and down. These waves have both electrical and magnetic properties and can travel through gases, liquids, and solids at nearly 300,000 kilometers per second, aka the speed of light. The wavelength shorter than the color violet is referred to as ultraviolet radiation, and the region with a longer wavelength than the color red is referred to as infrared radiation. Solar radiation includes visible light, ultraviolet light, infrared waves, radio waves, X-rays, and gamma rays. Radiation is the transfer of this energy by electromagnetic wave motion. Once the sun's energy reaches Earth, it is intercepted first by the atmosphere. A small part of the sun's energy is directly absorbed, particularly by certain gases such as ozone and water vapor. Some of the sun's energy is reflected back to space by clouds and Earth's surface. However, most of it is absorbed by Earth's surface. When the radiation is absorbed by a substance, the atoms in the substance move faster, and the energy is transformed into heat. This heat energy plays an important role in regulating the temperature of Earth's crust, surface waters, and lower atmosphere. Every surface on Earth absorbs and reflects energy at varying degrees, based on their surface's color and texture. Dark-colored objects absorb more visible radiation, where light-colored objects reflect more visible radiation. These differences in reflection impact temperature, weather, and climate. Now I will show you a video that further explains where the sun's energy comes from.
Space Place. In a snap. Where does the sun's energy come from? Every 1.5 millionths of a second, the sun releases more energy than all humans consume in an entire year. Without the sun, there would be no light, no warmth, and no life. Its heat influences the environments of all the planets, dwarf planets, moons, asteroids, and comets in our solar system. How does a big ball of hydrogen create all that heat? The short answer is that it is big. If it were smaller, it would be just a sphere of hydrogen, like Jupiter. But the sun is much bigger than Jupiter. It would take almost 1,000 Jupiters to fill it up. That's a lot of hydrogen. That means it's held together by a whole lot of gravity, and that means there is a whole lot of pressure inside of it. In fact, the pressure is so intense and the density so great that the hydrogen atoms collide with enough force that they literally meld into a new element, helium. This process, called nuclear fusion, releases energy while creating a chain reaction that allows it to occur over and over and over again. That energy builds up. It gets as hot as 27 million degrees Fahrenheit in the sun's core. The energy travels outward through a large area called the convective zone. Then it travels onward to the photosphere, where it emits heat, charged particles, and light. That heat powers the chemical reactions that make life possible on Earth, allows gases and liquids to exist on many planets and moons, and causes icy comets to form fiery halos. Those particles create a solar wind that pushes against the fabric of interstellar space, billions of miles away. And that light travels far out into the cosmos, just one star among billions and billions. Not too bad for a big ball of gas, no? Find out more about the sun at NASA Space Place.
So, knowing how this energy is created and absorbed can help us use the sun as a renewable source of energy. Solar energy technology harnesses the sun's radiation and converts it into heat, light, or electricity. Solar energy is a renewable resource, and many technologies can harvest it directly for use in homes, businesses, schools, and hospitals. However, solar technology is expensive and depends on sunny and cloudless local weather to be effective. Methods of harnessing the sun's energy are still being developed and improved, but it's still a great and efficient option. The sun has extremely important influences on our planet. It drives weather, ocean currents, seasons, and climate, and makes plant life possible through photosynthesis. Without the sun's heat and light, life on Earth would simply not exist. Thank you for watching.